Assalamualaikum warahmatullahi wabarakatuh. Today our group will be presenting about resistance welding, specifically about seam welding. So this is our group members. This is me, Muhammad DANISH IRFAN. The next one is Nur SYAZWIN, AMIR FAUZAN, and the last one is Nur FAIZAH. So what is resistance welding? Resistance welding is a welding process used to join steel plates together. When two steel plates are overlapped, moderate pressure is applied to the area to be welded, and an electric current is applied. The plates melt and adhere to each other due to resistant heat generation. The melted and bonded portion is called the nugget. Next is about key aspects of resistance welding. The first one is no filler material. Resistance welding doesn't require any additional materials like flux or filler rod. Second, it is a rapid process. The welding process is typically very fast and often taking only a fraction of a second. Third is a high current and pressure process. A strong electric current and significant pressure are essential for creating a strong and durable weld. The last one is various types. Resistance welding encompasses different techniques, including spot welding, seam welding, and projection welding. There are three types of resistance welding. The first one is spot welding. Spot welding welds form at individual points using two electrodes. Second is seam welding. Seam welding is a continuous weld made using rotating wheel electrodes. And the third one is projection welding. Projection welding use small projections on the workpiece for localized heat generation.
What is seam welding? Seam welding is a type of resistant welding where heat is generated by passing current through overlapping metal sheets, while pressure is applied using rotating wheel electrodes. Unlike spot welding, which make individual welds, seam welding produces a continuous weld seam, making it ideal for applications that need to be leak-proof, like fuel tanks or oil drums. The rotating wheels press the materials together while moving along the joint, ensuring a strong, consistent weld. So here is a diagram of how seam welding works. Two overlapping metal sheets are placed between a rotating upper and lower electrode wheels. These wheels apply boost pressure and electric current from the AC power supply. As the wheels rotate, they move along the joint and the resistance at the contact points create heats, fusing the metal into a continuous weld seam.
Seam welding is a continuous resistant welding process used to join overlapping metal sheets. First, the metal sheets are placed between two rotating wheel electrodes. These wheels are typically made from copper alloys, which provide excellent electrical and thermal conductivity. Next, pressure is applied, pressing the metal sheets together. This pressure ensures a strong mechanical contact, reducing electrical resistance at the contact points and allowing efficient heat transfer. Once the pressure is set, a high electric current is passed through the electrodes. This current creates an intense heat at the points of contact, where electrical resistance is highest, allowing the metal to reach its plastic or molten state. Finally, as the wheel rotates, they move the metal sheets through the welding zone. This motion creates a continuous series of overlapping weld nuggets, forming a strong and uniform seam. The process is carefully controlled to ensure the weld quality is consistent along the entire seam. Moving on to the components. First, the rotating wheel electrodes. These are usually made from copper alloys for high electrical conductivity and durability. They apply both pressure and current to the metal sheets as they rotate. Next, the power source, which provides the necessary electrical energy for the welding process. It includes controls for adjusting the current, voltage, and weld time, ensuring the proper heat is generated. A control system is also essential. It regulates the welding parameters like current, pressure, and speed. Modern control systems often use programmable logic controllers or PLCs for precise control over the welding process. Finally, a cooling system is critical to prevent overheating. This system often using water or air cooling. maintains the temperature of the wheel electrodes, thus extending their lifespan and ensuring consistent weld quality.
Now, let's look at some application where seam welding is used. First is in transformer. Seam welding is used in making transformer, ensuring strong and continuous welds. Next is paint containers. It also used for paint containers, making sure the seams are leak-proof. Third is gasoline tanks. Seam welding is essential in creating gasoline tanks where a strong, leak-proof weld is crucial for safety. The last one is in automobile mufflers. Finally, it used in automobile mufflers where durable, leak-proof seams are needed to handle high pressure. So the conclusion, to sum up, seam welding works well in application, it's needing strong, continuous, and leak-proof joints, like in transformer, paint containers, gasoline tanks, and automobile mufflers.
Advantages of seam welding. Seam welding has several key advantages. First, it produces leak-proof and airtight weld, which is why it's used in full tank and seal container. It's also fast and efficient, especially for long straight welds. Since it doesn't require any filler material, it saves cost and time in production. Plus, seam welding works well in automated environment, making it ideal for mass production in industries like automotive and appliances. Lastly, it gives consistent weld quality, reducing defects. So here's an example of a sealed container like this shipping door, where strong continuous welds are critical to keep the content protected from air, water, and pressure. Seam welding is often used for this application because it creates airtight and leak-proof welds, making it ideal for container, tanks, and similar seal structure. Next, seam welding works very well in automated production line like the one shown here. Since the process uses rotating wheels and steady pressure, it can be easily controlled by robotic system, ensuring fast, repeatable, and consistent welds, perfect for industries that rely on mass production, such as automotive and electronics.
Let's talk about the limitation of seam weldings. Firstly, welds only up to 3 mm sheets. Seam welding is best for thin materials, usually up to 3 mm thick. It doesn't work well with thicker materials. Next is straight or curved path. It can only weld in straight lines or simple curve, so it's not good for complex shapes. Third, it requires special equipment. Seam welding needs special machines with rotating electrodes, which might not always be available. The last one is limited to lap joints. This process is mainly used for lap joints, where one piece overlaps the other. It doesn't work as well with other types of joints.
To conclude, SIMS welding is an efficient and reliable process. It provides strong and continuous weld, ideal for airtight and leak-proof application. SIMS welding also suitable for mass production because it provides high-speed automation, making it ideal for industries like automotive and packaging. SIMS welding also best for thin metal sheets. It delivers consistent quality on thin materials such as steel and aluminum. SIMS welding have low material distortion because it being controlled by heat and pressure to minimize warping of the workpiece. And the last one is ideal for specific application such as fuel tanks, radiators, and cans. So that is all from us. Thank you for your attention.